Alright, so here's what we're doing today, guys. We're gonna be putting a new compressor in this truck here. Obviously, I'm not really an automotive tech. I know all you, my loyal subs, know who I am, but this is for any people that have just come across this, doing this job. I mostly do residential heating and air. But what I wanted to show you guys today is just the basic overview of what a automotive AC is comprised of, and also some tools that you can get to be able to do these repairs without buying the expensive one-and-all machine from an automotive snap-on Robin-Air type deal. So let's come over here. We're in our shop here. Here is basically everything you'll need to work on ACs in cars as well. This is a recovery machine. This is an old beater. They have lots better ones these days that run you about $600 to get the nicest one, but I'm sure you can find one on eBay or Craigslist for $100-200. This is the recovery cylinder. This is a cheap disposable one. But basically this machine has an input and an output, so you hook those up to the car. Obviously you hook the car up to the input, you hook the output from the machine to the tank, and it's going to pump all the refrigerant into the tank with this machine. So you'll need that obviously to get rid of the old refrigerant. This is a tank of dry nitrogen. We use this to pressure test and to blow out the system. You really should never use compressed air. It's got too much moisture in it. It's not good for the system. This regulator is really all you need to buy, and then you'll have to buy it one tank, and then you can trade them out. They're really cheap, and it's really smart to use this to flush systems and to pressure test them. And what we have here is my little vacuum pump, and this is the vacuum kit. This is a micron gauge. This is a much better way to check your vacuum levels rather than just using a gauge on your manifold. This is a neat product. This is a oil type goop. It's really good to use on O-rings and seals and stuff. It's probably even better than oil, so you guys can look that up. It's called Nylog if any of you want to use that. So you have just the basic tools you'll need. What I have here, these are just some fittings to use my regular gauges on a car. I know most of you will have gauges that are made for cars, but you can get those as well. Here is the new compressor. This compressor is a little different than some cars. It does not have a low pressure switch. I believe this right here is what we would call an unloader. So when the pressure is low, the compressor starts to not pump as much Freon as when the pressure is higher. The full pistons and the mechanism engages and it is full capacity. What this is a accumulator, and it's also the filter dryer of the system. So it's got little basically it's got something like this inside this shell that absorbs moisture. And we have a new orifice tube. This is what actually controls the amount of Freon going to the evaporator. It's also what creates the pressure drop in the line. So what we have here is high pressure liquid, and then it has to go through that tiny little tube, and it comes out here as a low pressure cold. So on this side warm, this side cold Freon. And it is still mixed a little bit of liquid vapor mixture, still evaporating off, but as you can tell, it's got a screen to keep any contaminants from blocking the tube. But that is what an orifice tube looks like. Got some seals, we've got the oil, and a little measuring cup. I just wanted to do a quick preview, show you guys some basic tools that you can use without spending the big bucks on that do-it-all machine. And once we have some of the parts bolted on the truck here, I will have my gauges hooked up and we'll go over some of the readings and what different issues will show on pressure gauges. So here's that accumulator. It is in the suction line. There is no liquid line dryer. Down here, if you guys can see that, you have to take this nut loose, separate this line, and that is where the little orifice tube is. Here's the compressor, and in a nutshell, this is a pump. All it is a pump. We're pumping Freon. This is the outlet. This line is going to be very hot. It is a high pressure, high temperature vapor coming through this line. This line goes to the condenser, which is in front of our radiator. The condenser's job is to change it from a high temperature, high pressure vapor to a high pressure, lower temperature liquid. So this is the inlet to the condenser, and this is coming out of the condenser, this line here. So this line will be scalding hot, and it will not be a liquid, it's a vapor. This line will be warm, not as hot, so it's rejected some of the heat, and it's also changed it from a vapor to a liquid. So we got liquid here, just like a garden hose. And what you can think of happens right here is, think of that sprayer on the end of your garden hose spraying the liquid Freon. So this is where this side of the orifice is that liquid stream that's warm. This side of the orifice is going to be the low pressure, colder side. So this is the inlet to the evaporator. So we've got that low temperature liquid vapor mix going into our evaporator. Now we're going to be able to absorb the heat from the cabin into the evaporator, and we're going to boil off the low temperature, low pressure liquid Freon into a low pressure, higher temperature vapor. So at the top of the evaporator, all of the liquid should be boiled off and it should be just vapor. This little bottle is a little chamber to let any liquid collect at the bottom, because basically this compressor cannot pump liquid. It's got to be vapor. So yeah, this compressor cannot pump liquid. It's got to be vapor. So this helps trap any liquid that might make it through the evaporator in here. So a Txv, some people will, there are Txvs on cars, and Txv is a mechanical assembly that can adjust. See, there's nothing that adjusts the rate of flow through that orifice I showed you. Let's go get it again. I want to try to keep it clean. There is basically nothing that will adjust the rate of flow through this orifice. Of course, the pressure inlet is really the only deciding factor of how much Freon goes through a simple orifice tube. A Txv is acronym for thermostatic expansion valve. It will regulate the flow to constantly flood the coil, whether it needs to open more or close more. It will regulate the flow through the evaporator. Maybe what I'll get is, well, we could even go over here. Let's go over here. Let me show you what a Txv looks like on an air conditioner. Same principle in a car. This is our liquid in from the condenser. This is to the evaporator. This is a tube to sense the evaporator pressure. this is the tube to sense the evaporator temperature. It's got a little sensing bulb. Now some cars, all of this stuff is built into the valve, so you won't actually see it, but its theory works the same. It will adjust the rate of flow through this device based on the evaporator pressure and the evaporator temperature. So if the evaporator is colder, it will start to close off. If the evaporator is too warm, it will open up more, allowing more flow through it for any given set of temperatures. So a little bit of a higher technology. It's got some things in it that can malfunction. There's a little bit of freon in this bulb. It basically pushes force down on a little diaphragm in here, so stuff like that can go wrong. But what we'll try to do later is get into a little bit of what the readings will look like in a car on your gauges if either this orifice tube or a Txv is not opening right. So we're gonna take a little break. I'm gonna get to work on it, and we will pick you guys up later. Alright, so got the system taken apart, and I'm going to try a little trick. This is where the orifice tube is. It's inside this little stub, and it's kind of hard to get out, so I'm going to try a little trick. Let's see if we can pop it out with a little bit of nitrogen. There it went.
What you
I
find
had
at
to
home?
shoot your knife. I couldn't get nothing in that to get that orifice, so I had to shoot it out with some nitrogen.
Mm-hmm.
Woo-wee! Look at that.
Well, maybe it's the compressor seals, huh? That orifice was shiny and blingy.
Hey, look, it started to cave it in there.
Dang, man.
It's like almost
A bunch of crud.
sand or something. That's sand. Doesn't it look like sand?
Yeah, it was probably ground up parts.
Yeah.
See, it seems like ground up matter of some sort, not sand, because it doesn't feel gritty. Just rub it around in your fingers, but it's ground up parts.
It's almost like mud though, like oil.
Yeah. Mm-hmm.
Probably stop leak.
No, I'm bad, but I'm not lazy. I'll clean it off and see what it looks like. See if it went through the screen or not.
I'm gonna start flushing this thing out. I got some blue rags here if you want them. We're gonna start flushing everything out here.
Let's see what you do. Pretty good now.
I don't know, man.
Got a lot of oil out to start with. But it's
Mhm.
clear now.
You wanna. The big test is gonna be what the heck comes out of this condenser. Let's try to flush it and back flush it. May need to switch my tanks out. This one's kind of starting
You want
to.
to go from that end to here to blow
Yeah,
it?
let's start that way, and then maybe we'll back flush it if we can. Ready? There's the other end.
Nothing. It's pretty clean. How fast are you going in with it?
Not very much.
Okay. I was gonna say, would you ever
I need to switch out my tank. Yeah, it wasn't really pushing back on me like when I would just blow it.
Yeah. Well,
Seemed pretty good.
Yeah. I think that's good and it's clean. I didn't see any oil or nothing coming up out of there.
Yeah, it's scary though. Do you want to use
think
any
there's a
chemical, or
strain.
do you want to just?
I think there's no strain or anything in the condenser.
Well, it's a microchannel though, so what's going to happen is those ports start getting blocked with that gunk.
Yeah. I don't think it needs any chemical. It doesn't smell really bad. It just had that degree of
Yeah, that's what
compressor coming out.
I think what I would do is I would run this thing for a month and I would change the orifice again.
Go check the orifice.
Mm-hmm.
You know how
Got
you
to.
do that.
You got to though. I mean, they give you plenty of O-rings, but this one's O-rings from days. Get another. You got to kind of pull the accumulator, or maybe pull the.
Yeah, you gotta get the accumulator out of the way to
Mhm.
get to it. Because even if you pull this whole reserve bottle, you can't get to the bottom of it very well.
All right, I'm gonna change the nitrogen out, and we'll hit it with a little bit stronger. I was done flushing it. Really, nothing much came out. Y'all saw how nasty that orifice tube was. Can't stress enough to use this nitrogen to do that, not shop air. It's time to reassemble it.
So I gotta look back on the other one.
You want me to put this in there or
I
no?
don't know. It's
I
a few months
wouldn't.
old. It might have absorbed moisture, but I kept the top on pretty tight.
I'd probably get you a can, because I think you'll be fine. There's at least an ounce kind of still floating
If you want
through.
to use some for your threads and stuff like that, just use that.
Yeah.
Very cool.
Well, good luck, little fella. Alright, we got everything reassembled, and now we're going to do our pressure test with the nitrogen. Now this is kind of obviously a fancier set of gauges that you guys don't need. So this is just dry nitrogen, and we don't use Freon to pressure test because the pressure will vary with temperature. Nitrogen won't do that. Well, it does it a little bit, but it doesn't do it much. So we're going to zero out. put it in 134A. Okay. High side. Low side. A little bit of oil in there. All right. All right, so let's open up the high side. I'm putting it in through the high side, but low side's coming up too. Just takes a little bit. We don't want to get too carried away on the pressure. If this was a AC system that I'm used to working on, I would probably pump it up to 250 or so, but okay, so this is the pressure that we are starting at. This is the pressure that we are at right now. This is the pressure that's changed. It's compensating for the slight change in temperature with this clamp. So we'll pick this up and we'll see how we do here after a little while. Alright, well, as you can see, she is more taken apart than before. That's why I stressed about the pressure test. The pressure was not holding, it was dropping. It's a micro leak, it's a tiny one, but we ended up finding a leak right down here in the condenser, so we kind of confirmed it. Also not too loving this new compressor. We were getting some hits with the electronic leak detector on the new compressor, so kind of disheartening. But the good news is, with all that debris that came out of the orifice, with a new condenser, the system will be even cleaner. And so I know I didn't get to really show too much of the vacuuming or the charging process, but when we work more on it, we can maybe get some of that footage and so forth. But yeah, nitrogen really helped diagnose the system before we did too much work vacuuming and recharging it. only to find that it still has a leak. So that's good, but not so good that there's more work to be done. But all right, well, we will have a part 2